In this lesson, we're just going to go through a couple of simple examples looking at applying logarithm laws and properties. Before we start, I probably should specify some names for each of the log laws and properties that we've looked at, just for ease of communication over the entire topic. So first we'll look at the two properties. So when we look at log base a of a is equal to 1, we'll call this one log of the base. When we look at log base a of 1 is equal to 0, we'll call this log of 1. When we look at our first rule, log base a mn is equal to log base a m plus log base a n, we'll call this log of a product. And log base a m on n is equal to log base a m subtract log base a n. We'll call this log of a quotient. Log base a m to the power of p is equal to p log base a m. We'll call this log of a power. And finally, log base a of 1 on m is equal to negative log base a m. We'll call this our negative log law. Okay, so we're going to attempt to apply these properties and laws into a few simple scenarios. So the first example, we're looking to, without the aid of a calculator, evaluate the following. So in order to evaluate, what we're trying to do is apply our log laws to simplify. If we're looking at log base 2 of 32, our first thought needs to be that this 32 needs to be written using base 2. If we write this with base 2, then we'll be able to apply our log of the base property. So we can write this as log base 2 of 2 to the power of 5. We can use our power log law to say that this is 5 log base 2 of 2. And now this is log of the base, so this is equal to 1. And therefore we're left with 5. When we look at b, we have log base 3 of 81, and we need to put 81 in terms of base 3. So we have log base 3 of 3 to the power of 4, which is 4 log base 3 of 3, using our power law. And our log of the base tells us that this, again, is equal to 1. So therefore, we're left with 4 times 1, or 4. Okay, so pretty simple to evaluate without the use of a calculator when applying these log laws. When we look at the second example, we've got the same thing. So without a calculator, simplify the following. So the goal is to simplify rather than evaluate. If we can evaluate, we will. So we've got 2 log base 10 of 3. We have log base 10 of 16 and 2 log base 10 of 6 on 5. So we have a little bit of an issue. In order to be able to combine all of these things, they need to have the same coefficient, or they need to have a coefficient of 1. So I'm going to start by focusing on this one here, recognizing that we can write 16 as 4 squared. So once we've done that, using our power law, we can rewrite our log base 10 of 4 squared as 2 log base 10 of 4. So this power of 2 can be brought out in front. So now we have a common factor of 2. And if we take that out, we've got log base 10 of 3, log base 10 of 4, and subtract log base 10 of 6 on 5. So now they all have a common coefficient. We can combine the logs. So we've got 2 log base 10, and we have 3 multiplied by 4, using that product rule because it's an addition, and divided by 6 on 5, using that quotient rule because it's a subtraction. So 2 log base 10, 3 multiplied by 4. Now, if we divide by a fraction, we're multiplying by the reciprocal. So we have 2 log base 10 of 4 by 5, which is 20 by 3. So that gives us 60 over 6. And we've got 2 log base 10 of 10. Now log base 10 of 10 is equal to 1, so therefore we're left with 2 by 1, or 2. Okay, so a bit of a lengthy process to simplify that down. You don't have to show all those steps, but in this explanation, I believe it was necessary to go through that. Okay, so we're moving on to a third example now. In this example, we're looking to solve. So for each of the following equations, we want to solve for x. So by applying our log laws, we should be able to isolate the unknown. So log base 5, x is equal to 3. What we're going to have to do is write this in exponential form. So at the moment, the base is 5. So recall that this is our base, and the exponent will be isolated. So what we can say is that x is equal to 5 to the power of 3. And so therefore it's nice and simple now. X is equal to 125. When we look at B, we have log base 5, 2x plus 1 is equal to 2. So we have a similar scenario here. We've got our exponent, we've got our base, and our exponent. So therefore, we can say that 2x plus 1 is equal to 5 to the power of 2. So 2x plus 1 is 25. 2x is equal to 24, and therefore x is equal to 12. When we look at C, we have log base 2 of 2x plus 1, subtract log base 2 of x take 1 is equal to 4. Now this one's a little bit more complex. We have log base 2 and log base 2, so these two have the same log base and have a coefficient of 1, so we can use our our quotient law to combine them. So we can say this is log base 2 of 2x plus 1 over x take 1 is equal to 4. And so now we have it in a form where we've got our base and our exponent. And so therefore we can write this as 2x plus 1 over x take 1 is equal to 2 to the power of 4. So we have 2x plus 1 over x take 1 is equal to 16. And when we multiply both sides by x take 1, we get 2x plus 1 is equal to 16 lots of x take 1. 2x plus 1 is 16, x takes 16. We can subtract 2 from both sides, and we get 1 is equal to 14, x takes 16. Add 16, and we get 17 is equal to 14x, and then by dividing by 14, we get x is equal to 17 on 14. Now when we look at the last example, we have log base 3 x take 1, log base 3 x plus 1 is equal to 1. We have to take a similar approach. Now we have the same coefficient and the same base here, so we can use our product law, and that is that we can say this is log base 3, and we've got x take 1, and x plus 1 is equal to 1. We now have a scenario where we've got our base and our exponent. And so we can say that x take 1, x plus 1 is equal to 3 to the power of 1. By expanding this out and recognizing that this is a difference of perfect squares, then this is x squared take 1 is equal to 3. We have x squared is equal to 4 when we add 1 to both sides. So x will be equal to plus or minus 2 when we square root both sides. So that's it. That's our examples done. This will take a bit of practice to become fluent and familiar with log laws. Make sure you're taking time to review. Thank you for listening.